Let's apply the Moivres theorem to prove the trigonometric identity cos 3a equal to 4 cos cube a minus 3 cos a. For that purpose, let's state de Moivre's theorem. By de Moivre's theorem, cos theta plus I sin theta whole thing to the power n equal to cos n theta plus I sin n theta. So we have the identity cos theta plus I sin theta whole thing to the power n equal to cos n theta plus I sin n theta. We want cos 3 theta, so let's take n equal to 3. So we have, when you take n equal to 3, we have cos theta plus I sin theta whole thing to the power 3 equal to cos 3 theta plus I sin 3 theta. Now let's expand left hand side. For that purpose, we recall the identity a plus b whole thing cube equal to a cube plus b cube plus 3a square b plus 3ab square. We take a equal to cos theta and b equal to sin theta. B equal to I sin theta. We take a equal to cos theta and b equal to I sin theta. We replace a by cos theta and b by I sin theta. So cos theta plus I sin theta whole thing cube equal to cos cube theta cos cube theta. Plus b cube. B is I sin theta, so I sin theta whole thing cube plus 3a square b plus 3a square. So a is cos theta whole thing square, that is cos square theta, into b I sin theta 3a square into b plus 3a into b square plus 3a. A is cos theta into b square I sin theta whole thing square. Let's simplify this expression to have cos cube theta plus I sin theta whole thing cube is I cube into sin square theta. I cube is I square into I, and I square is minus 1, so minus I into sin cube theta. This one we can write it as plus 3 sin theta into cos square theta into I. Now I sin theta whole thing square, that's I sin theta whole thing square, that's equal to I square into sin square theta, and I square equal to minus 1, so minus 3 cos theta into sin square theta. We just have I square equal to minus 1 and I cube equal to minus I. Now let's plug this value of cos theta plus I sin theta whole thing cube in this expression. So we have cos cube theta, that doesn't have I, and this expression, the last one, this also doesn't have I. Let's write it separately. Cos cube theta plus 3 cos theta, sorry, minus 3 cos theta into sine square theta. Into sine square theta. Plus, out of this expression we can take I common. So plus, let's take I common and write it as 3 sine theta into cos square theta minus sine cube theta. So we have separated real part and imaginary part, and that's equal to, by de Moivre's theorem, cos 3 theta plus I sine 3 theta. Now, both left hand side consist of some real number and some purely imaginary number, and right hand side consists of real number and purely imaginary number. Now two numbers are, if two complex numbers are equal, then their real part should be equal. The real parts should be equal. So we have cos 3 theta equal to cos cube theta minus 3 cos theta into sine square theta. And also, let's simplify this expression or write everything on the right hand side in term of cos. Cos cube theta as it is. Let's write this expression totally in term of cos. Cos cube theta minus 3 cos theta sine square can be written as 1 minus cos square theta. That's equal to cos cube theta plus 3 cos cube theta minus 3 cos theta. Once again, that's equal to 4 cos cube theta minus 3 cos theta. So we have proved that cos 3 theta equal to 4 cos cube theta minus 3 cos theta. Now we can do compare the imaginary parts to get something extra. So we have compared real parts to get cos 3 theta totally in term of cos theta, Let's compare imaginary part to get sine 3 theta totally in terms of sine theta. So if we compare imaginary parts, then we have sine 3 theta equal to 3 sine theta into cos square theta minus sine cube theta. Now 3 sine theta, let's write it as it is. Cos square theta, we can write it as 1 minus sine square theta. So we are expressing everything totally in terms of sine theta only. And so we have 3 sine theta minus 4 sine cube theta. So in fact, we have not just proved that cos 3a equal to 4 cos cube a minus 3 cos a, but we have also shown that sine 3a equal to 3 sine a minus 4 sine cube a. So we have proved both the trigonometric identities.